Now, we are going to explore reactions of carbonyl compounds. And according to the syllabus book, according to the course outline, there are 4 reactions. There are 4 reactions of exploration. There are 4. However, I'm not saying that, okay, this is a restriction. This is a restriction. I am following what is on the grid, what is on the course outline. Those are the 4 reactions that are being outlined. I'm not saying that these are the only reactions which can be undergone by carbonyl compounds. For those of you who read a lot of books, you find other reactions such as carbamazine, glycine, aldol, among others. But these are the ones on the grid. Nucleophilic addition reactions, condensation reactions, redox reactions, reaction with iodine, those are 4. Yeah. However, I've said that there are others. For those of you who read a lot of books, you can interest yourselves in the following. Others. Others include other reactions include, you can look at glycine, aldol, carbamazine. Hope I'm writing correct spellings. Yeah, you can check on them, but they are off. They are off the course outline. So we want to start with the. What is this thing fake? We want to start with condensation reactions. Condensation reactions of. So condensation reactions are reactions of carbonyl compounds. We look at reactions of carbonyl compounds with derivatives, reactions of carbonyl compounds with derivatives of ammonia, compounds which are derived from ammonia. Ammonia is NH3. So ammonia itself is a derivative of ammonia. By the way, ammonia reacts with carbonyl compounds, and the mechanism can as well be outlined. So what are the derivatives of ammonia of exploration? We have hydroxylamine. So meaning that within ammonia, within NH3, remove 1 hydrogen and bring OH. You form hydroxylamine. And it has that formula. Then also hydrazine with that formula. Then with phenylhydrazine. Phenylhydrazine with this formula. Now, phenylhydrazine is obtained from hydrazine. If hydrazine looks like this, remove 1 hydrogen and bring a phenyl group. Remove 1 hydrogen. That's why we are having NH2, meaning that 1 hydrogen has been removed and replaced by the phenyl group. Therefore, I have phenylhydrazine. And the other compound is 2,4-dinitrophenylhydrazine. For those of you who read a lot of books, 2,4-dinitrophenylhydrazine is the same as Brady's reagent. It's the same as Brady's reagent, and in some books it is abbreviated as 2,4-DNPH. So if I use Brady's reagent or that abbreviation, I am referring to 2,4-dinitrophenylhydrazine. So how is it generated? Look at this phenylhydrazine. I have explained how phenylhydrazine is generated. Phenylhydrazine comes from hydrazine. Remove 1 hydrogen, introduce a phenyl group. So the hydrogens reduce, and in the process of reducing or removing 1 hydrogen, you introduce a phenyl group to replace that hydrogen, thereby coming up with phenylhydrazine. Now, after generating phenylhydrazine on this ring at 2 and 4, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. At 2 and 4, put nitro groups. At 2 and 4, put nitro groups. So meaning that at 2 and 4, I have nitro groups. Thereby, we have 2,4-dinitrophenylhydrazine. So I'm not saying that these are the only derivatives of ammonia which react with carbonyl compounds. I have also started by saying ammonia itself, moreover, reacts with carbonyl compounds. So there are many others. However, if you look at the course outline, or the syllabus book, they are stressing only two. They are stressing only two, that is hydroxylamine and Brady's reagent. They are stressing hydroxylamine and Brady's reagent. However, I want to comfort your hearts and tell you that once you know how they react with hydroxylamine and Brady's reagent, automatically you know how carbonyl compounds react with other derivatives of ammonia. I repeat, the grids, the course outline shows that we must explore only two condensation reactions: how carbonyl compounds react with hydroxylamine and also how they react with Brady's reagent. And to comfort your heart, I've said that exploration of those two, hydroxylamine reaction with carbonyl compounds and Brady's reagent reaction with carbonyl compounds, those two are enough to make you understand how all the other derivatives of ammonia react with carbonyl compounds. What are being formed? What are the products of these reactions? So once carbonyl compounds react with derivatives of ammonia, we form compounds. We form compounds with imine group. The imine group is a group of this form where carbon bonds with nitrogen. So this is what we call the imine group. So the reaction results in formation of imine compounds with imine group, and it is accompanied by a loss of water molecule. It's accompanied by the loss of water molecule, and that's why we have the name condensation. A condensation reaction is a reaction that involves loss of simple molecules like water, ammonia, etc. So since it involves loss of simple molecule, water molecule, that's why it is called condensation reaction. So I want to take some few examples. Before I take my examples, there is something important here to note. So I want to say that condensation reactions can occur. They can occur at room temperature. They can occur at room temperature. However, acid catalysis of the reaction increases its rate of occurrence. I have said that condensation reactions can occur at room temperature, and there are two cases here of exploration. They can occur at room temperature. However, if you apply an acid, once you apply the dilute sulfuric acid, acid catalysis of the reaction increases its rate of occurrence. So by acid catalysis, I mean acid catalysis with preferably dilute sulfuric acid. Yeah. So now I take some few examples. Hope that is taken note of. So examples of condensation. Examples of condensation reactions. So don't forget that by condensation reactions, we mean the reactions of carbonyl compounds with these compounds which I have mentioned, with those compounds which I have mentioned. And I want to say that the reaction mechanism follow the same pathway. However, I'm going to create a distinction between, I have said, as I create a distinction, I've said that we can have a reaction occurring at room temperature and also when it is acidic catalyzed. Therefore, examples of condensation reactions, we have two cases of exploration. In absence of a catalyst, and also in presence of a catalyst. Those are the two cases of exploration. So examples, I am going to have part A, case 1. How am I calling case 1? Case 1, this is absence of a catalyst. Allow me first stop here.